So, today, we've looked at direct proof. They exist. Those are going to be our main focus. Now, with the exception of today, always two-column proof. Today's a little different. Today's a weird day. I'm not going to test you on it. I might ask a question, but I'm not going to make you write one of these proofs. Not on a test. So here we go. 1.8, the very last section, we get this idea of indirect proof. Indirect proof. Bless you. Now, direct proof, literally all it means is start with hypothesis, end up at the conclusion. Sometimes that can be really hard. If I have something that I'm trying to prove, if P then Q, maybe it's really, really hard to get from P to Q. But I want you to do me a favor. That's a conditional statement. Henning, there's an electric one on top of the box next to you as well. Okay, no, I'm pretty loud. Anybody who sits in the front, I'm sorry, I just yell at you all day long. Looking at it, I want you guys to dig in your notes. We have a conditional statement. If P, then Q. There are 3 additional related conditional statements that change the order and negation and stuff. I want you to look back, find me the one that is logically the same as a conditional. It's either going to be the inverse, the converse, or the contrapositive. Are you sure? All right. So, we can use the contrapositive if we need to. If we are trying to prove that if P then Q, maybe that's too hard and we can show that if not Q, then P. But then not P, I'm sorry. Okay, there's one type of indirect proof. We will look at that in a couple minutes. Another really common one, and it feels like we're cheating when we do it. Yep, I would write this. Our first main topic, we will look at contrapositive proofs today, but we're going to start with this idea of proof by contradiction. Okay, for this, I'm going to talk a lot more than we write today. When we're looking at this, as mentioned, it can be really, really hard to start at statement P and end up at Q. And that could vary. It doesn't matter what the statement is. But if we're convinced it's right, like check this out. I think that if I drop this marker, it will fall. Everybody agree with that? Yeah. Now, this is an easy one to prove. But if it weren't super easy to prove, I can try to prove this thing by contradiction. And this is going to be a weird example because this isn't math. But when we look at this, what if I said, okay, well, I'll assume that it won't fall. That's weird, right? That's the opposite of what we expect to happen. Yeah. If I assume that and show that it breaks, and I show that there's contradiction because it did fall, I've convinced logically that we're true. That's a weird statement. We'll do a couple of these. But I'm going to assume it doesn't fall. And then I drop it. Did it fall? Yes. We just contradicted it. And it feels circular with a marker example. But that is the essence of what we're doing. We'll do a mathy one here in a second. We're going to check this out. We're going to write this really concisely. Step 1, and we're just going to write this in like 3 steps. Step 1, we will assume the conclusion is wrong. The conclusion is wrong. Now, there's another way that we could word this. If my conclusion is Q and it's wrong, then it's like we've negated it. What does that mean? Negation, not Q. We assume not Q. That's what's really happening here. We assume, how do I write not without 3 letters? Tilde. Assume not Q. That's the negation. We just assume that the conclusion that we're after is false. Okay, once we do this, step 2, show that this leads to a logical contradiction. This leads to a contradiction. And this is a really important part. What is a contradiction? Something that proves something wrong. I want you and your neighbors, I'm going to give you a minute, come up with a statement and a contradiction for it. If you have no idea what a contradiction is, I don't know how it's defined. We can Google it real quick. Contradiction. A combination of statements, ideas, or features of a situation that are opposed to one another. Check it out. I'm going to just give you a really easy one, and then I'll give you real quickly. I'm going to be a contradiction right now. I hate bright clothing. Why? Hey. Yeah, I'm obviously contradicting myself, right? Okay, that is an example of contradiction, something that goes against something else. Can you come up with another one?
I can swim.
You don't wear shoes.
I don't wear shoes. I see clearly. The rain is gone. No, that's just it.
Wait, I can swim.
You can see so
Can you swim? Then that is it. Yeah, I'd say it's a false statement. Okay.
No, I can't swim.
I will never drink water from a bottle. I just did it, right? Like, I'm contradicting myself. Your parents might do it all the time. If you've ever heard an adult or a parent say, do as I say, not as I do, that's because people are contradictive by nature, right? Like, I'll say one thing and then I'll do that exact same thing that I told you not to do. It looks like hypocrisy, maybe, and it is. Okay, so show that this leads to a contradiction. If I assume that my conclusion was wrong and it shows me that I'm making nonsense, what must have been the case about my original conclusion? If I say, I assume my conclusion is wrong and then it shows like, no, this is nonsense, then do we agree that the conclusion must have been right?
Yes. Yeah.
And if the conclusion was right, have I shown that that statement must have been true all the time? Boom, there's our proof by contradiction. Show this leads to a contradiction, and then therefore, once we have a contradiction, step 3, we will identify that our original conclusion, and I'm going to say that Q, that is our original, must have been true. Identify. ID. Been true. Now, because I'm not going to write test questions regarding this, we're not going to go crazy into it. They're not going to look quite like 2 columns because the logic does feel like we're not really doing anything sometimes. Let's do one. So here we go. We're going to write at least one proof by contradiction. The most important part is we have to assume that the conclusion is wrong. So here we go. I want the following example. If angles A and B, if these 2 angles, A and B, are complementary, and I'm going to call them complements instead, then the claim is that the measure of angle A must have been less than 90 degrees. If I give you 2 angles and I tell you that they're complementary, I'm claiming with certainty that one of them must have been less than 90. And maybe it's both of them, realistically, but at least one of them is all this says. Is that a true statement, first of all?
Could one be 0 degrees and one be 90?
Could you draw an angle with 0? So, no. Nope. Weird statements. Maybe. We're going to say no for now. But it's a great thought. Not a weird statement. Great thought. Okay. Is that true? If 2 angles are complements, then one of them must be less than 90.
Yeah.
Why?
Because complementary, they have to have 2 that add up to 90.
Okay, so let's check this out. Like, it has to be the case, right? They have to add up to 90, and let's think this out. If I was writing a proof by contradiction, which we are, what do I assume? So here we go. These ones are going to look very different. We're going to physically write the word assume. And we'll probably mostly talk through them because it's just a string of words, like it's just sentences when we write these. Okay, 2 columns, what I really care about, but I want you to see this idea, the logic of it. What's the negation of measure of angle A is less than 90? Don't shout it out. We're going to go 60 seconds. Write me the negation of this. Make it so it's the exact opposite. Try it out and I'll see what you come up with. We assume something about measure of angle A.
The measure of angle A is not 90. I don't say it out loud. He said just write it down.
You were really close. Like that's the opposite. Okay, gut feeling. Who says, and you maybe don't feel really confident, but you should, the measure of angle A is greater than 90?
Yeah.
You are so close. You are so close. There's only one little thing.
Greater than or equal to.
If it's 90, is that negation? That's not less than 90, right? So if you had greater than 90 degrees, you are super duper close. Let's just assume that measure of angle A is greater than or equal to 90. Measure of angle A is greater than or equal to 90 degrees. Okay, that is our assumption. We are assuming that the conclusion is wrong. Oops, sorry. Now, we are looking, sorry? Because if it's not less than 90, that could be 90 or bigger, right? That's it. Okay. Now, we need to show that this hypothesis then is contradictory. If this is the case, we need to show something that breaks. If I tried to take any other angle, let's just look at this. We're going to look at the Matthew version. Now, if I were to do measure of angle A plus the measure of angle B, what do you guarantee that they add up to bigger than? They have to be greater, so it would be greater than 90 degrees. Do you guys agree with that statement? Like logically, it's there, right? But here's the issue. What do we say A and B were to begin with? They add up to 90, and then that was our original hypothesis. And this is contradiction, right? Because this says they don't add up to 90, they add up to more than 90. Does that disagree with our hypothesis? Yeah. We contradicted it, right? So here we go. Go ahead.
So if the contradiction is false, does that make the...
So if the assumption here leads to a falsehood or a contradiction in your hypothesis, you're good. That's the whole idea. I'm going to write a but statement. But A and B, measure of angle A, plus the measure of angle B, what was it supposed to add up to?
90.
Was supposed to be 90 degrees. Can we all see that these two statements are at odds with one another?
Yeah.
Okay, that is our contradiction. This is the contradiction. Check it out. New math symbol. Therefore, what must have been true about our original conclusion? Here's our original. Must that have been true if making it false led to nonsense? Yeah, therefore, the measure of angle A must have been. And that's the goal. So there will be ones where you try and you can't find a contradiction. Or that you're just not good enough at math. Not you specifically, but people in general. Must have been less than 90 degrees. And look at that, we're done. Does it feel like we've really truly written a proof here? Maybe for some of you. Michelle.
Are there situations where an indirect proof would work better than a direct proof?
Absolutely. Absolutely there are. There are not going to be many situations for us where that happens. But in mathematics, absolutely. I might ask you conceptually about them, but I'm not going to make you write any of them on your own. But it's nice to see that more logic than we cover exists. Okay. I would never give you a proof by contradiction and say prove by contradiction using two columns. Never. Never. Never, never, never. Okay. So we're going to try. Does that feel okay? Like it's weird, but it exists. Are we good with it? Okay. We have what, 5 minutes? We're going to talk about this other part. We're going to write one more proof. If we have a statement if P then Q, it's logically equivalent was a contrapositive, right? What's a contrapositive? If I give you the statement P then Q, what's its contrapositive? Not Q, then not P. Okay, so that's kind of like what we did just now, a little bit, right? We just showed that if not the conclusion, then not the hypothesis. Now, we can do it much more structured. Sometimes, and this is going to be our quick second section, and again, no homework, but we're going to go right up to the bell. Cool. Yep. Proof by contrapositive. We will not have homework so long as, like, we keep doing what we've been doing. I haven't had to get on anybody. What's up? Why not? I don't know. I don't know. No idea. I switched here. I did it here so you could tell that this is the part that we talked about. Yeah. Yeah. I'm envious. All right, here we go. I want you guys to tell me to make sense of this. We are proving if not Q, then not P. That's the goal. So let's check it out. I'm going to make somebody help me read this one. And actually, I'm going to give groups a second. I'm going to write this mathy, okay? Here's our proof. I'm not going to say any of it. N, euro symbol. Crazy Z. Double arrow. N, euro symbol. Crazy Q. So a circle, and it's almost like an H. Yep. It's called a blackboard Q, just so you guys know. We did not write Q on the board up here. I'm going to give you 30 seconds. Try with your neighbors. See if anybody near you can read this statement with words, not N euro symbol. What does this say?
And in the set of integers implies and in the set of.
We don't know what Q is.
Okay, I wonder if I wrote it down. Wait, I know what Q is first. I was on exactly what.
Bless you. Okay, so I heard people coming through with the right spots. In the interest of time, here is how I would say this. Now, you could be more formal than this, but the claim that we see here is that if n is an integer, n is in the set of integers, then n is in the set of rationals. Okay, that's all this says. First thing that I care about, because we've used integers before, I think in here, if not, 1, -1, 2, -2, 3, -3, 0. On and on forever. What's a rational number? So 1 and 2 are rational numbers.
Numbers that aren't infinite, like pi.
So that's irrational, but I like it.
A number that can be expressed as a fraction.
Yeah, give me another word for fraction. Ratio. They're the ratio numbers. Okay, 1 over 1, 2 over 1, or 2, or 3, or 4. Doesn't matter, right? You make a fraction. You cannot do that with pi. Pi is not a rational number. You cannot do that with infinitely many numbers. The square root of 2 is another example of one that you can't write as a fraction. You just can't do it. Okay, so here's our statement, and we want to try to write this using a contrapositive. Notice, our hypothesis is it's an integer. Q is it's a rational number, right? That's our original statement. What should we assume then?
N is not a rational number.
Assume n is not rational. Okay. Why? Because when we're doing contrapositive is the only good reason I have. Was it you that asked why, Michelle? Yeah. Okay. If we're trying to prove this by contrapositive, we have to negate. We're trying to show that if not the conclusion, then not the hypothesis. Okay. So here's our not conclusion, right? The negation. What does this mean if a number is not rational? It's irrational. It means that I cannot write it as a decimal or a fraction, right? So we'll just go one step further. So then we would conclude from here, n is a non-repeating decimal. Do you guys agree with that? If it's not rational, we could not write it as a decimal that stops. So pi is an example. If it's pi, then it's non-repeating decimal. Okay. We have one more step away. What's not Q? Sorry, not P. So let me rephrase this because we're getting goofed up. Here was our original not Q, right? And then I just added some logic to say, well, this is what it really means. If this is my original P statement, what is not P? N is not an integer, right? What's an integer? Give me examples. 1, 2, 3, 4, -1, -2, 0. All of those, right? How many integers do we need decimals for or ever use decimals with? Do we ever write decimals with integers? No, you don't need them. Okay? But check it out. We just said it's not rational, then it's a non-repeating decimal, which is not an integer. Would you agree with that? If it's a non-repeating decimal, it's definitely not an integer. Okay? Which is not an integer. Which is not an integer. Okay, here's the weird part, and here's why we don't test on them. Does it really feel like we've made any meaningful progress just now? But check it out. We have just shown that if it's not this conclusion, then it's not this, and it's similar to contradiction. We've just shown the contrapositive was true. Sometimes this is easier than showing the conditional. Here's the good news. You guys have seen and are aware that different types of proof exist. Different types of proof exist. Are we ever going to write another one of these proofs? Not in this class. You have no homework this evening. Cool. I didn't get time to pass those back. I will pass back a ridiculous amount of stuff tomorrow. Tomorrow, you will be working through a group practice test. Cool. Jonah, I would just tell everybody no. Good on you.